I want to start this video about effective teaching by talking about dating websites. So when these dating websites were first launched, users would go on, create a profile, and list things they were looking for in an ideal mate. But as the dating sites examined the data of which couples were making it into lasting, healthy relationships, they realized that couples who were perfectly matched according to their ideal lists almost never made it as couples. But when perfect matches couldn't be made, those non-ideal pairings more often led to enduring relationships. So the dating websites did something sneaky. They still asked users for qualities in an ideal mate, but they used a new algorithm that didn't directly align with these stated ideals. And the new algorithm, the one where people weren't paired with their ideal mate, has proved much more effective in creating sustained relationships. The point I'm making is this: our intuitions about what is best for us are often dead wrong. We see the same phenomena in learning as well. What we have discovered broadly across our careers and research is that optimizing learning and instruction often requires going against one's intuitions. This researcher, Robert Bjork, actually discovered this idea of what he calls desirable difficulties accidentally. His team was researching how well a training program taught groups of technicians. However, with the very first group of technicians there was a mistake. The instructions the technicians were supposed to follow were actually sent to them out of order. Bjork actually wanted to scrap this first group of technicians from the research project, as his intuition told him there was no way these technicians were going to learn the material now. But his team convinced him to record their performance data, so he did. And it turns out this first group of technicians, the ones who got their instructions in the wrong order, the group that the researchers thought were going to crash and burn, actually outperformed every other group of technicians who got the instructions in the correct order. And that got Bjork wondering, maybe we've been thinking about teaching all wrong. Maybe giving students the simplest way of knowing something really isn't the best way for them to learn it. Which wasn't exactly a new thought. You might remember learning about this guy back in college, John Dewey, when your education professors were like, he's the man? Well, here are a few things Dewey said over 100 years ago. The origin of thinking is some perplexity, confusion, or doubt. As long as our activity glides smoothly from one thing to another, there is no call for reflection. And maybe that's why the technicians who got the out-of-order directions did better, because they had to stop and think about what steps should actually be first and why. They had exercised their brains a little bit while going through the activity, which led to deeper, more meaningful connections about how the machine functioned. In a later study by Bjork, a group of students were instructed about 12 famous artists using 2 different instructional styles. For one group of 6 artists, the students were taught using blocked instruction, meaning the students saw only Monet paintings all in a row, and then a group of Dali paintings together, etc. The other group of 6 artists were presented using interleaved or mixed instruction, where students might be shown one painting by Van Gogh, then one by Picasso, then Vermeer, then Braque, then Banksy. The students were then given a test asking them to identify which artist had painted which picture. After taking the test, when the students were asked under which style, blocked or mixed, did you perform better, students overwhelmingly said they performed better recognizing the artists from the blocked instruction. Again, this was after they took the test that they're saying they did better with the blocked instruction. But when we look at how well the students performed, overwhelmingly they did better recognizing the artists taught to them under mixed instruction. So why did the students do so much better under mixed instruction? The authors hypothesized that having to resolve the interference among the different things under study forces learners to notice similarities and differences among them, resulting in the encoding of higher order representations, which then foster both retention and transfer. It goes back to the fact that during mixed instruction, the students really had to grapple or struggle with the content. They really had to do some heavy cognitive lifting to fit the information into their knowledge bases. Here are 2 more quick examples where mental struggling seemed to pay off. The first example involves 12-year-olds being split into 2 groups and then tossing beanbags. Group A were given targets that were both 2 feet and 4 feet away. Group B were given targets that were 3 feet away. Both groups were then tested on the target that was 3 feet away. And Group A, the group who never practiced at the 3 feet range, significantly outperformed Group B, who had practiced only at that 3 feet range. A second example involves a college varsity baseball team. During batting practice, Group A knew what pitches were going to be thrown to them. 15 fastballs, then 15 curveballs, etc. The second group got random, unknown pitches thrown to them. After 6 weeks, tested twice, once where the batters would know the next pitch, and once where the pitches were random. That second group, the group that trained with random pitches, significantly outperformed their peers on both tests. So here's why I think this research is so important. As teachers, our intuition is to help students. That's why most of us became teachers. And our intuition often tells us that when a student is struggling, it's our job to help relieve them of that struggle. It feels good afterwards, and occasionally a student might even smile and say, "Thank you." But I think as educators, we need to rethink what help should look like from a teacher, and that perhaps by not letting our students struggle, we might actually be doing them a disservice, because we aren't letting them get that needed cognitive exercise. I'll leave you with one more quote from Bjork. Conditions of learning that make performance improve rapidly often fail to support long-term retention and transfer, whereas conditions that create challenges and slow the rate of apparent learning often optimize long-term retention and transfer. Thanks for listening.